Hello and welcome to the video presentation of methods time measurement and user interface design. My name is Michael Morrow, and in this presentation we will introduce the concept of how methods time measurement can be used to improve the interaction between people and machines. The user interface is the space where interactions between humans and machines take place. Examples of user interfaces include the interactive aspects of computer operating systems, hand tools, heavy machinery operator controls, process controls. An effective user interface is designed in such a way that makes it easy, efficient, and user-friendly to operate a machine in the way that it was intended. In general, this means that the operator needs to provide minimal effort to operate the machine through the user interface. MTM stands for Methods Time Measurement and focuses on the manual motions used in a process. MTM is a procedure which any manual operation is analysed into the basic motions required to perform it and assigns to each motion a predetermined time standard, which is determined by the influencing factors, for example the distance reached and the degree of control under which it is made. In the original MTM system, MTM1, the basic motions are reach, grasp, move, position and release. For simplicity, a second generation MTM system was developed, MTM2, where the basic motions have been combined into motion sequences get and put. In this presentation, we'll be focusing on the application of MTM1. MTM can improve the design of user interfaces by focusing on the manual motions of the operator interacting with the machine. MTM recognizes each manual motion has a time element apportioned to it. Typical motions of the operator at the user interface include finger motions, for example typing, pressing buttons, grasping objects. Eye motions, eye travel and eye focusing, for example eye motions required to read the text on a computer screen. Hand and arm motions, reaching and moving objects, alignment of objects. Trunk and lower body motions, twisting of the body, bending down, stooping, pressing foot pedals, and walking. The user interface design can be improved by reducing the number of finger motions, eye motions, hand and arm motions, and also trunk and lower body motions. The designer will inherently reduce the time taken for the operator to interact with the machine, reduce the energy expended by the operator, which improves the ergonomics of the user interface design. To explain how MTM can be used to improve the design of the user interface, it is best to use an example to show how MTM can be applied. A well-known example of a human-machine interface is the computer keyboard. The keyboard design most commonly known as the QWERTY keyboard, named as such due to the arrangement of letters on the top row of letters on the keyboard. We're going to compare the ease of typing a sentence on the QWERTY keyboard with that of a lesser-known alternative keyboard layout, the Dvorak keyboard. The Dvorak keyboard has been around since the 1930s and is in fact even included as an option in Microsoft Windows. People who prefer the Dvorak keyboard argue that it's more efficient to use than the QWERTY keyboard. Let's use MTM to calculate any quantifiable difference in the two keyboard layouts. For the MTM analysis, we will apply the MTM1 system due to the amount of finger motions in the typing process. We will assume the operator is an average but experienced touch typist. The fingers of the typist will rest on the home keys and will return to rest on the home keys after depressing other keys on the keyboard layout. While the operator is reading the sentence to type, the operator is not looking at the keyboard while typing. Muscle memory is being used to press the appropriate letters and returning to the respective home keys. The thumb on the right hand is positioned above the spacebar to press the spacebar as required. For both the QWERTY and Dvorak keyboards, the operator has the same level of typing experience. We're going to type "The quick brown fox jumped over the lazy dog." This sentence utilizes all 26 letters of the alphabet. We will then review the process of analyzing the finger motions used in the typing process and calculate the process time. We will repeat this process with the Dvorak keyboard layout. Let's start. In the MTM1 analysis, we used MTM1 to analyze the typing motions for the QWERTY keyboard. The analysis involved breaking down the process into smaller elements. For each element, determining the motion sequence and MTM1 code used for both left and right hand, taking into account the distance the hand is moved and the degree of control required. Assigning the predetermined time values for each motion sequence code, adding all of the time values for a total process time. The process time derived from the MTM1 analysis for typing the sentence on the QWERTY keyboard by an average experienced operator is 12.5 seconds. Let's now review the Dvorak keyboard using the same process. Like the previous analysis, we used MTM1 to analyze the typing motions for the Dvorak keyboard. The analysis involved breaking down the process into smaller elements. For each element, determining the motion sequence and MTM1 code used for both left and right hand, taking into account the distance the hand is moved and the degree of control required. Assigning the predetermined time values for each motion sequence code, adding all of the time values for a total process time. The process time derived from the MTM1 analysis for typing the sentence on the Dvorak keyboard by an average experienced operator is 11 seconds. From the MTM1 analysis, we found a quantifiable decrease in the time taken to type a sentence. In this case, a 1.5 second improvement. During the analysis, we identified less finger strokes were needed in the Dvorak keyboard, as the vowels A, E, I, O, and U were positioned as home keys. 1.5 seconds may not seem significant, but think about the time savings for typing a 100-page document. From this example, it can be seen that the MTM process can be used to justify changes to designs to improve the effectiveness of user interfaces. As well as for physical devices like keyboards, the MTM approach can be used in software design, reviewing the keystrokes, mouse strokes, and eye motion required to navigate and operate a graphical interface on a screen, for example. In fact, using MTM, we encounter first time right, as it becomes easier to bypass iterations of user interface design improvements by determining the most user-friendly method before it is implemented. That's something to think about.